I'm so excited to be in Lithuania. This is my first time here. How do kids learn to code? This was a question I was asking myself about 5 years ago when, this just fell out, hold on. When I was managing the construction of a city farm in San Diego, California. We were building a farm, and adjacent to the farm were classrooms, and we were building a kitchen with the hope of teaching kids how to grow and prepare their own food. And we had a classroom that had no set purpose. And I really thought that it should be a tech classroom, that we should take on the goal of offering computer programming to the kids that we served. My hurdles were that I am not a programmer. I knew nothing about programming at the time. I didn't know how to teach kids how to program. I didn't know how to learn how to teach kids how to program. And so I arrogantly named the classroom the tech classroom anyway, and figured if I built a tech classroom, the tech would come. And it did. It did in the version of teaching kids programming. A curriculum called TKP Java had been created by Lynn Langet, who was our keynote speaker this morning, and she had a team of volunteers. And 5 years before this, they had taken on the challenge of creating courseware in the Java language that would teach kids how to program. Up until this point, most of their work had been event-driven, meaning they had done one-day, 3-hour events, but they had done them all over the world. And in those 5 years, they had really figured out a lot of truths about how kids best learn how to program. Their work was highly inspired by Harold Abelson, who wrote the book Turtle Geometry. I believe it's 1981 or 82. It's out of print, but you can still find copies of it. He surmised that you could use the computer to teach geometry, and the visualizations that he uses in this book, the geometric visualizations, are used throughout the TKP Java curriculum. We learned that words really provide the bridge, that kids obviously learn in language, and we used linguistics a lot in the creation of this curriculum, and it looked like this. So if you look on line 13, it says move the tortoise 50 pixels, and then the Java translation is tortoise.move 50. And so it was very easy for the kids to see how you translated from English, which they were very comfortable with, to Java. What we used was Eclipse, a simplified version of Eclipse. So this is what the first module looks like. The very first lesson of the very first module is called Simple Square. And if you look, we're using the English to translate to Java and to create the graphic. 1 line of English equals 1 line of code. Once they translate the English into Java, they delete the English comment so that when they work with the code in the future, they'll be reading code and not reading English. At first, the English comments are pretty much the same as the Java code. This changes even within this very first recipe. Step 4 is the first time that the English is not directly translated, and this is when they're introduced to setters for the first time. It's also where they learn to read the documentation. We were careful to not have the documentation give them the exact answer, but just give them the pattern that would allow them to find the answer. And we added color samples to the Java docs. Step 4, they're introduced to a for loop. And it auto-formats when it saves. In the next steps, after they've created a simple square, they will learn how to refactor that square to create other visualizations. The courseware now includes 8 modules, about 80 lessons, and if you would like to use it, it is open source. It is also not funded, so it's not supported, but you are welcome to fork it and use it as you would like. It's at teachingkidsprogramming.org. So now I had my, yes? Great, thank you. We say that when kids are really competent on keyboarding and mouse skills is when they are about the right age. For us, we really aim towards the 10 to 14-year-olds. So now I had my farm, I had my tech room, I had my kitchen, and I had my courseware. And what we have learned in the last 5 years is 7 rules that we basically live by for how to take this foundational TKP Java courseware and teach kids how to program. And rule number 1 is don't assume. When we first came up with this idea that we were going to teach kids, I knew what the goals were. Our goals were that boys and girls would work together. I am the mother of 3 sons, and when I started working and volunteering with TKP, I started also being asked to volunteer at hackathons, primarily all-girl hackathons. And when I would ask, I have a son who would like to come, and he's nice to girls. That wasn't really an attractive idea to the people running the hackathon. And so for me, I wanted experiences where my sons would learn how to work well with girls, and these girls would learn how to work well with boys. And so one of the core principles of all of my work has been normalizing boys and girls working together. We also wanted to provide 20 to 30 hours of coding in 1 week. Up until that point, like I said earlier, we were pretty event-based. We would do a 3-hour or 2-hour Saturday, and so while we would introduce the curriculum to kids all over the world, we didn't have the opportunity to do a lot of follow-through. So I really wanted to get a hold of these kids pretty much full-time during a week. And we were catering to mostly 11 to 14-year-olds. The reason we chose that age group, because this courseware works great for high school also, but this was the age group that was really not being served. For younger kids, there was a lot of drag and drop picture programming available, and then once you got into the higher grades, there was some courseware in the schools and then obviously in college, but those middle years, there really wasn't anything, and we had really learned that that's where you lose kids and they lose interest. If you don't catch them at that age, by the time they get to the higher grades, they don't feel qualified. They feel like they don't know enough to enroll in these classes. And so those were our goals. And we came up with the idea of doing a coding summer camp. But my concern was those girls. I didn't think that if I set up a camp and called it a coding summer camp that I would get a lot of girls. I thought I was going to get all boys. And we were discussing this problem in my kitchen where we were not assuming we knew the right answer, because we don't assume, rule number 1. And the 15-year-old in the kitchen came up with the answer. He said, do a cooking and coding camp, because if you add cooking, you'll trick the parents of the girls into thinking it's for girls. And so we did. We set up a registration for cooking and coding summer camp, and we got 50% girls and 50% boys, and it sold out in 8 days. But something really fascinating happened, because the truth is, the 11 to 14-year-olds do not make the decision of where they're going to summer camp. Parents make the decision. And the parents of the boys just signed them up for summer camp. The parents of the girls called me and said, is this summer camp for girls? And I'm like, yes. And they said, well, I thought so, because it has cooking. So we knew that was a thing. So we had 60 kids that first summer over 3 weeks, and they completed the TKP Java. They didn't complete it. They did a lot of the TKP Java courseware. We also did other technical introductions to them, and they made delicious Greek cuisine. When we were deciding who should teach this camp, we went with the obvious, which was the 15-year-olds we had. Our 15-year-olds, that is my son, Brick, at 15, and that is Lynn's daughter, Samantha. And we decided, since we were trying to create a really new experience for all these other kids, we would also create a really new experience for our two 15-year-olds and give them their very first paid jobs. And so they were hired as the computer programming summer camp teachers. And they were uniquely qualified because they knew the courseware inside and out. They had been our testers for so much of it. But something that we did not expect happened by hiring them. They are only a few years older than the kids enrolled in the camp. Brick is tall. He's probably twice the size of Samantha. He's tall, he's blunt, he's loud. Samantha is patient and quiet and, quite frankly, much more kind than Brick. But they team taught, and what these campers got to see was a boy and a girl a few years older than them working together as a team. And they were very respectful of each other. They never interrupted each other. If somebody asked a question that Samantha had expertise on, Brick would defer to Samantha to answer that question. And by just having them in the room with these campers, they modeled behavior that was then mirrored by the campers, and they treated each other the way they saw these older teenagers treat each other. At the end of camp, I asked a couple of the campers, so who was in charge? Who was in charge in the classroom, Brick or Samantha? And they looked at me confused and said, Brick and Samantha. And so we had really, I think, created something we didn't even intend to, was this perfect model of how to treat each other and that it was okay to work together. Summer number 2. Summer number 1 was such a success that we decided to do it again the next summer. At this point, our teachers had matured in their teaching. Samantha had actually been hired by a private school in her town to teach the TKP Java curriculum as an after-school activity. And Brick had gotten to go to Horton Works in Silicon Valley and train interns on how to teach kids how to program. But we were lucky enough to get them back for summer number 2, along with 60% of the campers we had from summer number 1, which gave us an interesting problem because we couldn't just repeat what we did summer number 1, and these kids had now been out in the real world with a new technical knowledge, and they came back with ideas about what they wanted to do. Rule number 2 is work in groups and have food. I have found that the trick to getting any group of programmers happy is food, and these kids are no exception. We also always pair program, or we pair program in groups. There are times that there's only one computer going with a whole room of kids, and we put it up on a projector and they work on things together. Working together in a more social environment makes everything safer for them because they are succeeding and failing, not alone, but with somebody else. And we found that they're willing to try harder things if they know that they're going to succeed or fail together. We also have no rules. Although we are constantly looking at how the kids are working together and are always looking for ways to have boys and girls working together, sometimes they just separate. The girls go in one room, the boys go in the other. We never tell the kids what our goals are. We just create an environment that we hope will inspire them. And most 85% of the time, they're all together. I was ecstatic when they came back from school and after a year from the last summer, and they kept asking us about data science. And I studied statistics in college and loved data visualization. I have been really inspired by the work of David McCandless. He's a British journalist, and he started using data visualizations to tell his stories. He has a company called Information is Beautiful. And so having the kids back and say, we would really like to learn more about data was very exciting to me. And so one of the things that I have always learned is that anytime you teach kids, if you get to teach them about something that's important to them, they will be willing to work more for you. And there had been a really big argument, summer one, in the kitchen. And that argument was, how do you make the perfect hummus? They had made hummus several different ways, and they each claimed that they had, yes? Yes. Mm-hmm. I have an answer for you on that. So what he has asked is that I earlier talked about how English would translate to Java and how, pretty easily it did. We actually have had several teachers and worked with them, and what we do is if you're not a native English speaker and the kids you're working with are not native English speakers, then what you would do is under the English comments is add in the comments in your own language, and so it would go English to your own language, and then they would translate it, and it has been surprisingly very successful doing it that way. I know that there are people who have translated it German, Swedish, Spanish, and then actually Arabic. So it works great to do it that way. Thank you. So hummus. They had arguments over hummus, and so we decided that we were going to answer this question once and for all. The big arguments were, should the garlic be raw or roasted? And should the chickpeas be peeled or unpeeled? And so they made 400 servings of hummus, and then we started working on our survey. And I asked the kids, what question are you going to ask the people that you test this with? And they said, well, we'll just ask them, what's your favorite hummus? And I said, well, but the problem with that is that then you receive no information about the 3 other hummuses. And we used experimental design to create the environment for them on creating these surveys. And so they went home, each of them with way too much hummus, and they came back with all of these data sets. And then we put them to work. We said, you have all of these data sets. They don't match perfectly, so you're going to have to figure out a way to combine them, and then you're going to have to answer a query with a data visualization. We told them they weren't allowed to use words. They could use numbers, and we gave them full reign to the art closet and the walls. And they created huge data visualizations answering the questions about hummus. And the answer is roasted garlic Peel chickpeas. Rule number 3 is fail big. I'm always surprised, and I was one of them, at how often people think that programmers just code everything right perfectly the first time. And so if they are having any struggle, it's because they're just not a good programmer. In the farm, we often ask the question, how many seeds are you planting? This was inspired by a 5-year-old who we were planting carrots, and I saw him on the table carefully counting out carrot seeds, and I said, what are you doing? And he said, well, I want 12 carrots, so I'm going to plant 12 seeds. And I thought, oh, that is never going to work out. You have to plant a lot more seeds than that if you want 12 carrots. And I think that's something that sometimes is a frustration for a lot of us, is that we feel like we do work that kind of goes nowhere. I will tell you, we had 60 kids the first summer. I'm not here to tell you that we have 60 computer science majors at university, but we have some. And so I'm always very excited to get to plant computer programming, give the experience to as many kids as possible. And we do have success stories for that nothing is wasted. Also, we constantly tell the kids that mistakes grow your brain. And so whenever they fail big, we applaud them for failing big and ask, what did you learn? And they almost always report back that they learn more from the failures than they do from the successes. And so creating an environment where failing is celebrated because of the learning as much as successes are is really important. It was really important because the next thing the kids came up with, at this point, they had really taken the lead in what they were going to learn. They started telling us what was important, and then we just had to catch up with them. And one of the things that they wanted to do was they wanted to light up the windmill. We have a 23-foot tall windmill that is it's set up actually in dirt in the farm. And in order to turn the lights on, you would have to walk out in the dirt and plug them in. And if it was muddy, you would get muddy doing it. And the kids came up with the idea that there must be some way to turn on the windmill without having to walk through the mud, and that would be a problem they could solve. We solved this with an electric imp and a power tail. An electric imp is an IoT device. It's based out of Palo Alto and Cambridge, UK. And I have found it to be the easiest to use with kids. It's very simple. You program in the language of squirrel, and they really like it, and it's inexpensive, which is important when you need to buy a lot for a group of kids. And so they worked through trial and error figuring out how to do this, and they wrote a very simple phone app so that they could turn the windmill on and off with their phones. Actually, anybody could turn it off with their phones. Rule number 4 is be surprised. After our second summer, we had a core group of kids that had spent 2 summers with us and really showed a lot of interest and asked us to provide something for them during the school year. And so we used the model of you guys. We took user groups and put teen in the middle of it, in front of it, and did a teen user group. And it was fairly informal. They would meet anywhere from 1 to 3 times in a month. And this picture was actually orchestrated by the girls. They wanted to take this picture. And so we do have a lot more boys in the user group, but when this picture was taken, the boys were balancing on a log out in the farm. And so that's why they're not in this picture. But they really took over their education. They completed the foundational TKP Java courseware up until that point. And then they started coming up with other ideas. They now felt like they kind of had a handle on hardware with the IoT devices, and they had a handle with software with the TKP Java, and they had, an introduction to data science, and they came up with some ideas, and this is one that we actually did. And this was Pi Day, which is March 14th. And they thought it was really funny that the Raspberry Pi could also be a Raspberry Pi. Remember, we have a kitchen. We have a kitchen. So they wanted to bake Raspberry Pis and program Raspberry Pis. And the project that they came up with was hooking up proximity sensors to the Raspberry Pi computer, programming in Python. They set up a recording booth, and they recorded themselves saying scary things. And so when you would get within 3 feet of their Pi, the proximity sensor that was hooked onto the Pi tin would go off, and through the speakers, you would hear them yelling at you to get away from their Pi. I'm going to show you what that looked like.
All my life. Do not eat it. Don't eat me, I'm poisonous!
So here we're creating delicious key lime and raspberry pies, and then later we're going to create pie protectors for them.
In your actual pie, and you're going to program your Raspberry Pi, so when someone gets close to it, it's going to be like,
Please don't eat me, or blood will be spilled.
The pie stealer, floating in the ocean. Where did he go? He decomposed.
We obviously had a really enthusiastic videographer that day. Rule number 5 is show your work. We always encourage the kids to show their work and to show it to other kids. Actually, Raspberry Pi Day, they invited a whole other group of kids that were doing some programming work to come to the kitchen to do it with them. That's why you saw so many kids. But I also started thinking I need to start showing some of my work. And so I invited an industry leader in our community to come to a really simple 1-hour workshop we were doing. It was once the students have the first 4 modules of the TKP Java, they really have a foundation, and I have found that that's the point where you can start introducing them to IoT. And so we do a 1-hour workshop where they do the hello world of IoT, which is lighting up an LED light. So I invited him to come do that. And I invited him to pair program with one of the kids. This was his partner. And the two of them worked together for an hour in a room full of kids. And at the end of it, he asked me if there was anything he could do to help. And I said yes, that we wanted to be a nonprofit, and that takes funding to do that. And he funded us based on that 1 hour. And that is what created TKP Labs. TKP Labs, I'm the director of TKP Labs. And This was really our goal once we had all these wonderful successes in the tech room with the kids. We wanted more kids to have that experience, but obviously our small little group couldn't do it. And so we really wanted to start training teachers. And when I say teachers, we have trained actual school teachers. We have also had corporations that have hired us to come in and teach their engineers or their interns, and they turn around and work in their community with the students in their community. And so we have been really fortunate in getting to have a lot of our work spread. TKP Labs, my entire goal with TKP Labs is to have teachers that can teach students to the point of where they feel qualified to go into a computer science class at the university, qualified to go into computer science at a higher school education. That as long as they feel qualified to continue with a computer science education, I think we've done our jobs. Rule number 6 is take risks. We use the word risk a lot with the kids, because taking risks and choosing difficult tasks really increases your growth mindset. We were really inspired by the work of Dweck. I would encourage any of you to look into her work. But we had never really had a lot of risks thrown at us. We'd had some interesting invitations. I was actually lucky enough to get to go to London and work with UK Youth, which is their big youth organization, and the Think Hub O2. We had done some work in Africa. We had done work in Silicon Valley and New York. But our biggest challenge came when we were asked to go to the West Bank for 3 weeks and train 24 teachers to teach computer programming. This was funded by a Google grant. And they wanted a manual. We did not have a manual, a teacher's manual. And that was when we really learned teachers like a manual. So we had, from the time we said, yes, we'll go, we had 9 weeks. And so we created a teacher's manual in 8 weeks. And we loaded up all of our paraphernalia and took off to the West Bank. For 3 weeks, we trained 24 teachers. And those 24 teachers were half men and half women. And the result was that next school year, over 400 students were taught the entire TKP Java Foundation and the IoT Hello World workshop. We had some really interesting experiences there. One of the things is we brought a lot of fun games, computational thinking games to break up some of the training days. And I remember that, being so surprised because one of the games had a golf ball, and the teachers informed us they'd never seen a golf ball in real life. So as you travel the world, you never know what you will be introducing to new people. Rule number 7 is to feel powerful. If you can get your students or yourself to a point where you feel powerful, you'll be able to do anything. Summer number 3, Samantha actually had the opportunity to study data science and biology at Stanford University. And so we needed another teacher to work with Brick. And these 2 girls had been with us, Tristan and Angelina, since summer 1, and they were members of our teen user group. And so we were able to give more teenagers their first summer job. And Brick trained them, so he had a new experience, and they were fantastic. And so we really knew we had a model that wasn't just about our 2 teenagers, but something that could continue. One of the big things that I have learned, in fact, probably the biggest, is that you can never identify a programmer to be. If you, at any given time, if you put 20 kids in front of me to teach a camp to, I would not on day 1 or day 5 be able to tell you which one was the one who was going to want to continue. And I want to show you a video that some of our kids did. And there's five coders in here. One of them is attending school next year as a computer programming major, and I wonder if you can tell which one it is. Actually fast forward Jax because he's kind of an overachiever, and it takes 1.5 minutes to get all the way through this so you can see what it does. It's really cool. Jack's great. Yay. Seriously. Oh, we're not done. We lost the sound. So the answer is, does anybody have a guess over who's the computer? You wouldn't dare guess, right? It's the shot putter. Maddie, the shot putter, continued technical education. She took computer science classes in high school, which is grades 9 through 12, and she wants to be a computer programmer for a living, and so she's starting university next year to do that. So once again, I would never have been able to guess it was Maddie out of everybody else. Another opportunity that we've had is to work with the very underprivileged kids in Malawi, Africa. Justin, up there, is my co-director at TKP Labs, and we have been very lucky to be able to, we've had people, Hewlett-Packard gave us some laptops, and we were able to take them to Malawi, but the work that they're doing in this tiny little tech school in Malawi is really amazing, and Lupita is our most recent graduate, and after graduating the tech school in Malawi, she was offered a full-time job at the technical college in the capital city and offered her education also. So TKP Labs is now being, or TKP Courseware, TKP Java is now being taught on 6 continents. We are not in Antarctica yet. And TKP Labs has done teaching training all over the world. And I feel hugely fortunate to be able to do this work. I love working with teenagers. I love working with teachers. And trust me, 5 years ago, I didn't know how to do any of this. But there are so many people who are willing to say yes if you ask for a volunteer to help. Next summer will be our 6th summer, and the 2 teachers, Samantha and Brick, are away at university now, studying mathematics and bioinformatics. And so our 2 teachers will be Ty and Angelina. Ty is my son, and they were 11-year-old campers, year 1, and they are all ready, and they have their own ideas of what they're doing this next summer. They will do the TKP Java foundational work, and then they have a lot of stuff from all the things that they've learned over the last 6 years. So what should I do? What should I do? I hope that you're asking that question. And the answer is to volunteer. Go help a teacher. Go help a youth organization. Walk in and say, I have skills and I can help children learn these. And if you give the children, I encourage you to use the TKP Java curriculum, but do what works for you. This is just what has worked for me. But if you give those kids the foundation, they will start telling you what they need next in their technical education. Thank you so much for having me.